Hello everyone. So today we're going to be discussing surjectivity in functional equations. So now surjectivity is probably one of the most important assets to have when solving a functional equation. So in this video, we're obviously going to be looking at surjectivity, what surjective functions are, maybe some mappings and all, mapping diagrams and all. But more importantly, what the crux of it is going to be is how to maybe identify in a given functional equation if that particular function is surjective. Or if you have multiple functions, both of them may be surjective or one of them may be surjective. Any possibility may occur. And obviously using surjectivity to kind of like simplify our solution a little bit. So yes, let's see how we can explore this. Okay, so this is problem number A1 from the IMO shortlist in 2002. So A1 is algebra 1 and the shortlist is basically all of these countries, they propose certain problems that they think should come on the IMO and then certain problems are selected from them, right? So this is the first problem of the algebra part of the shortlist. Okay, and in this video, we're going to be discussing surjective functions, what they are, what is surjectivity, and investigating surjectivity in functional equations, very important, right? And we're also going to be looking at a solution without surjectivity or injectivity because, that might not click in your head in the exam. So might as well look at an alternative solution. Then we have certain book suggestions for functional equations, and at the end, a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so what have they given us? They've asked us to find all functions mapping from reals to reals so that it satisfies the given functional equation for all reals x and y. Okay, perfect. So, let's do this thing. Let's first maybe try and look at a solution without surjectivity. And then we look at a solution with surjectivity. Right? So first, let's just use maybe some elementary substitutions. So what we can start with? We can potentially start with maybe some substitution. Let's just, let's say put x equals to 0 and y is equal to y. Let's just start with this. You could have gone vice versa also, but it's fine. So this gives us with f of 0 plus y is equal to f of y. Right? Okay, great. Now the next thing that I can do is maybe I can put x equals to y and y is equal to 0. And the idea is that I'll get something similar to this and you'll actually see how. So I'll get f of y and y is 0 obviously. So you see that this and this are actually the same is equal to 2y plus f of 0 minus y. Right? So essentially what I can conclude from this is f of 0 plus y. So if I just label this equation number 1, equation number 2, the right hand side over here and the left hand side are equal to, you can just equate the other sides, is equal to, I will get 2y plus f of 0 minus y. Right? Okay, great. So now what I'm going to do is I'm just going to define f of 0 plus y to be equal to m. Similarly, I'm going to define f of 0 minus y to be equal to n. And if you actually try to compute m minus n, you'll actually see just 2y. Because the f of 0's get cancelled. Okay, that's great. So now what we can see is that this essentially is f of m, right, is equal to m minus n plus f of n. If I just send f of m to the other side, I'll get this f of n minus n. And now if I introduce a function g of x, so let's maybe introduce g of x, and that will be equal to f of x minus x. So g of m will be f of m minus m and g of n will be f of n minus n, right? So we can easily see that this is nothing but g of m is equal to g of n. And this actually holds true for all m comma n, right? So therefore g is a constant function. So the idea behind this is, for example, if let's say g of 1 is equal to g of 2, right? But then this holds for all m and n. So g of let's say 700 is equal to g of 700 and let's say 7 or whatever, right? It's hold for like all numbers m and n, right? So that essentially means that g is a constant function, right? If all the values are the same, that essentially means that it does not depend on any particular value of x, which means it's a constant function. There is no x in the expression for the function g. So therefore I can essentially that g of x equal to c. No matter what the value of x, you'll get the same output. So if g of x is equal to c, then what was g of x? G of x was essentially f of x minus x. So c is equal to f of x minus x. And f of x is actually x plus c. And now really at this point, the only thing that is left for us to do is to find out this value of c. And how do you do that? You just plug this back into the original functional equation and see if there is some particular value of c, the constant, for which it satisfies, or it satisfies for all value of c. So this was the given equation, right? f of x plus y is equal to 2x plus f of y minus x. Great. So I just plug in f of x equal to x plus c over here. So f of y becomes y plus c. So here we'll get f of x is x plus c plus y is equal to 2x plus f of y is y plus c minus x. Great. So this just becomes f of x plus y plus c is equal to 2x plus f of y minus x plus c. And what would this be? This would just be x plus y plus c is equal to 2x plus y minus x plus c. So if you actually look at the left hand side, it is x plus y plus 2c, and if you look at the right hand side, this becomes x plus y plus 2c. So actually f of x equals to x plus c is hold for all values of c, right? For all constant values of c. C is a constant essentially. So this is the solution to our given functional equation. Okay, so that was great. That was a good solution. That was a neat solution. But let's maybe try the method of surjectivity, So let's see how we can maybe solve this using the concept of surjective functions, right? So let's discuss surjective functions. So what are surjective functions? So surjective functions or surjectivity. Surjectivity is the name of the property, right? So it says that for every y, there should be an x such that f of x equals to y. So let's say a function f satisfies, it says, let's say there is a surjective function, okay? So if f is a surjective function, that means for every output y in its codomain must have at least one x in its domain, at least, okay? So for example, let's maybe draw some mappings. Okay, let's say this is the domain and let's say this is the codomain. And let's just mark some random elements. Let's say there are 3 elements. I'm representing them by dots. So every element in its codomain, this is first, this is second, this is third, and this is fourth, right? Every element in its codomain must be mapped to at least one element in its domain. So every must be mapped to at least one. So this can be mapped to this. Let's say this can be mapped to this, and this can be mapped to this. So something like this. Essentially, the point is if there are 4 elements or there are n elements in the codomain, every one of them needs to be mapped to at least one element in the domain, right? So in other words, essentially what we're trying to say is every element of the function's codomain is the image of at least one element of its domain, right? And this is essentially the mapping diagram of how it works. And this surjective function is also called as onto function, right? Onto, just another name for it. Right, so essentially what you need to remember for this is for every y there exists an x, which is f of x equals to y, right? F of x equal to y, or y is equal to f of x. Now let's look at a solution including surjectivity. Great, so what have they given to us? F of x plus y is equal to 2x plus f of y minus x. Now we need to kind of maybe figure out if the function f is surjective or not, right? And okay, so maybe we can just start with the substitution, right? That would probably be the simplest way to do this. So if I can just substitute y is equal to minus f of x, and if I just plug in maybe x equal to x, let's see what I get. I'll get f of x minus f of x. So it essentially the intuition to get maybe like a constant term. F of 0 is a constant term on one of the sides. 2x plus f of minus x, right? So it will be f of minus x, right? Minus x. Something like this, right? And on here we'll get obviously 0. So f of 0 minus 2x is equal to f of minus x minus x, right? Because essentially we replace this y with negative f of x. Okay, great. So now if you actually see that the right hand side is a surjective quantity, right? This entire thing, negative 2x plus c, is surjective, right? So if like the left hand side is surjective, the right hand side also has to be surjective. And what is the right hand side? It is nothing but the composition of certain functions of f. Right? F is a function, and the right hand side is the composition of functions. And if a composition of functions is surjective, that means f is surjective, right? Because composition and the original function both are surjective if one of them is surjective. So the left hand side is surjective, right? Negative 2x plus c, it's like a linear function. The linear function is always surjective, right? And if the left hand side is surjective, the right hand side has to be surjective, and the right hand side is simply a composition of f, which is surjective, so f also has to be surjective. Great. So now that we have proved that f is surjective, we can maybe move forward. So now that's now that once we have ascertained that the given function is surjective, after that things like become a lot easier, and let's just see how. So what I'm going to do is I'm going to take some alpha, okay, such that f of alpha is equal to 0. And the reason that I could do this is I could not let's assume some value f of a is equal to 0 without proving that it is surjective. We don't know if the function ever becomes 0 in its codomain, right? So there might not be an value of a such that f of a is equal to 0 if the function is not surjective. But because we have proved that it is surjective, we can essentially write it. Now it's perfectly valid. Right, so we took f of alpha is equal to 0. Now I'm just going to substitute x equals to alpha and y is equal to y in the given functional equation. And when I do that, I'll get f of alpha plus y is equal to 2 alpha plus f of y minus alpha. Okay, that's great because f of alpha is essentially 0. So I'll get f of y is equal to 2 alpha plus f of y minus alpha. Again, I'm going to plug in f of y is equal to z. So z is equal to 2 alpha plus f of z minus alpha. And now this is really reduced to simple functional equation. F of z minus alpha is equal to z minus 2 alpha. Now again, just replacing z with z plus alpha, I'll get f of z plus alpha minus alpha is equal to z plus alpha minus 2 alpha. So f of z is equal to z minus alpha. In other words, f of x equals to x minus alpha. Alpha is a constant, minus alpha will also be a constant. So f of x equals to x plus c. So yes, this is what we had received from the previous solution as well, without using surjectivity. But yeah, after this, you would again essentially just plug it back in the functional equation to try and find out a value of c. But like we checked before, it holds for all values of c essentially. So yes, that was a pretty interesting thing to know. And surjectivity in a way simplified our things, right? So if you like, the more problems you do, the more familiar we'll get with it. And once you figure out that the function is surjective, after that this is just one substitution that you had to do, and this the problem pretty much ends there at the level of the IMO shortlist. Okay, so I really hope you enjoyed that. Great. So we have certain book sessions of functional equations, how to solve them by Christopher G. Small, and functional equations by B.J. Venkatachala. Both are really great books. Right, so finally we have a similar but tragic problem, and I wanted to find all functions f and g such that g is injective. They've given us that g is injective, and they satisfy the given functional equations. So maybe try a little bit of surjectivity over here. Surjectivity, the idea of surjectivity or proving like these functions are surjective will really be helpful and will really simplify the question a little bit. So yeah, if you're able to make any progress on it, or if you're able to solve it, let me know in the comment section below. And until then, I'll see you in the next video. Thank you very much, and bye-bye.
Cheenta programs are designed for students who are passionate about mathematics. And they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.